Greetings everybody, and welcome to example 6 in our series on cross products. So what we have in this problem is that we're asked to use the properties of the cross product to find the magnitude of the cross product of a vector u and a vector v. Well, what's special about this particular case is that if we notice something about the vectors u and v, that in particular for our vector u, we have 0, 0, 8, and for our vector v, then we have 8, 9, and 0. So kind of looking at the first two components for v and seeing a 0 in the third component, that tells us that v is contained in our xy plane. While as our vector u, the first two components are going to be 0, and we only have a third component, which tells us that our vector u is perpendicular to the xy plane because it is only pointing in the positive z direction. And so the shortcut that we can take in this case is that the magnitude of the cross product of u and v is going to be equal to the magnitude of u times the magnitude of v times the sine of the angle between those two vectors. But because our vector v is going to be contained in the xy plane, u is going to be perpendicular, then because those two vectors are perpendicular, our angle in between is going to be 90 degrees, and so our sine of 90 degrees is just going to be 1. And so we get that the magnitude of the cross product is just going to be the product of the two magnitudes of the two vectors. And so what we have then for the magnitude of u is just going to be 8. The magnitude of v then is going to be the square root of 8 squared plus 9 squared. And so what we have is just 8 times the square root of 145. So sometimes we are able to use the magnitude of the cross product, or we're able to use the properties of the cross product to take a shortcut when we see that those two vectors that we're given have that kind of special property to them. So keep an eye out for those, and I will see you guys in the next video. Take care.